All right, let's get right into it. We use computers all day, every day. But let's be honest, for most of us, they're kind of like a magic black box, right? We do something and something else happens. Well, today we're going to pry that box open and take a look at the brilliant and surprisingly simple logic that makes it all tick. So, have you ever really stopped to think about that? That split second, it feels instantaneous, like magic. But it's not. It's actually this incredible high-speed dance between all these different parts. And stick with me here, because by the end of this, you're going to know all the steps to that dance. And here's the wild part. Whether we're talking about the tiny computer in your smartwatch or these massive supercomputers that predict the weather, they all, and I mean all of them, run on the exact same super simple three-step mission. It's like the DNA for all of computing. And this is it. The whole shebang boils down to these three steps: input, process, output. Simple, right? First, the computer has to take in some raw data, like you typing on the keyboard. Then it gets to work. It processes that data. And finally, it spits out something useful, the output, like the letters appearing on your screen. That's the loop, over and over again. Simple, but wow, is it powerful. Okay, so to make this whole input, process, output thing happen, a computer isn't just one single blob of electronics. It's way better to think of it like a team of specialists where every single part has a very specific job to do. So let's meet the crew. First up, we've got the input unit. This is the team's receiver. Its whole purpose in life is to listen to us, the humans. When you click a mouse, tap your screen, or even talk to your device, that's the input unit's cue. It takes what we do and translates it into a language the computer can actually understand. Once that signal is translated, it gets sent to the undisputed star of the show, the CPU, the central processing unit. This is the brain. Seriously, this is where all the action is. The input unit just passes along the message. The CPU is the one that actually reads it and figures out what to do next. All the heavy lifting, all the thinking happens right here. But even a genius brain needs a place to lay out its tools and papers, right? And that's where the memory unit comes in. Let's call it the team's workbench. It's this temporary, super fast space where the CPU keeps all the stuff it's working on at this very moment. You've probably heard of it as RAM. Without this workbench, everything would grind to a halt. All right, so the CPU has done its thinking on the workbench. What's next? Well, the job gets handed over to the output unit. This is the team's presenter. Its job is the exact opposite of the input unit. It takes the computer's finished work and translates it back into something we can understand. The picture on your screen, the sound from your speakers. You get the idea. So there you have it. That's the main team. But now I want to go a little deeper. Let's zoom right in on our star player, the CPU, because it turns out the brain isn't just one single part. It's actually got its own little two-person crew inside. Yeah, this really nails it. When we say it's the brain, we're not kidding. This is where the magic happens. It's the engine of the whole machine. So let's pop the hood and see who's in there. Okay, inside the CPU, you've got two main components working together. First, there's the Arithmetic Logic Unit, or ALU. The easiest way to think of this guy is as the calculator. It does all the math, all the logic. Is this true or false? Is this number bigger than that one? All that stuff. Then you have the Control Unit, the CU. This is the manager. The CU doesn't do any of the math itself. Instead, it's like the project manager telling the ALU, the memory, and everyone else what to do and in what order. It's the conductor of the entire orchestra, and it's doing this billions of times a second. That gigahertz speed you always hear about, that's this manager working at an insane pace. All right, we've met the whole cast of characters. We know about the team and the dynamic duo inside the brain. So now we can finally answer that question from the beginning. Let's follow one single key press on its incredible journey from your finger all the way to the screen. Step 1, you press a key. That's it. That physical action is instantly detected by your keyboard, our input unit, which turns it into a unique digital signal. Next, that signal flies, and I mean flies, straight to the CPU. The first one to see it is our manager, the control unit. It catches the signal and immediately knows, okay, I've got a new task, and starts telling everyone what to do. Following the manager's orders, the necessary info, like what program are you even typing in, gets pulled onto the workbench, our super fast memory unit, so it's ready to go. Now the manager points to the calculator, the ALU, and gives it a job. Hey, figure out exactly which tiny dots of light on the screen need to turn on to make this letter appear.
The ALU crunches the numbers in a flash and comes back with the result. That result, basically a blueprint for the letter, gets sent off to our presenter, the monitor.
And boom, the right pixels light up and the letter you pressed pops up on the screen. The whole thing, that whole journey we just described, happens so fast you can't even perceive it. And your computer does this over and over and over again for every single thing you do.
So what's the big takeaway here? It's that a computer isn't some magical black box. It's a system, a really logical, beautifully designed system of specialists all working together. You've got your input unit, the CPU with its manager and calculator, the memory unit workbench, and the output unit, all of them cooperating perfectly.
And that simple model, that input-process-output loop, it's not just for your laptop. It's the foundation for your phone, for your car, for supercomputers, for almost everything. It's just an incredibly simple idea that has completely reshaped our world. Which really just leaves you with one big question, right? What problem is it going to solve next?